Hi, I'm Avinash Sajwan and welcome to my channel Engineers Mania. I am a postgraduate student from IIT Kharagpur.
Digital elevation model are very important raster dataset to store the values in a raster format, and it is very much used in ArcGIS and QGIS formats for evaluations of different quantities. So DEM is very useful, but how to get it? One source is that you can get the ready-made DEMs from different sites for India like Bhuvan and USGS also. But what if you want to create a DEM of your own using Google Earth and some other features? So I'll show you today how to create your own DEM so that you can perform your independent calculations on such raster datasets. First of all, let's go to the Google Earth and type in the location where you want to create a DEM of your site. So I'll go to a site Chamoli, where a recent lake outburst flow happened and a whole hydropower project was destroyed. As you can see in the previous year model, like in 2017 or 19, previous to the landslide and lake outburst flow, you can clearly see the hydropower project as well as the bridge as well as the village nearby, which is unaffected and not damaged, and people are living and working there. But after the landslide event in February 2020, you can see that the bridge has been washed away, the road structure has been damaged, the hydropower completely washed away. So now we would like to have a calculation of change detection in these two sites with these respective times. What I mean by change detection is that how much deposition has been occurred and how much erosion has been occurred in this area. So for that we will need two DEMs which hold the elevation values, and when we subtract those DEM we will get the difference between the elevations, which can be correlated with the deposition as well as the erosion in the area. So we will like to click on the add path. We will name this path as pre-event, and what I want you to do is hold your mouse left click button and hover over the area which is your area of interest. Like for the outermost points, you don't need to have so much clarity, but the area where you want to have a little bit higher resolution, you need to go slow over there and try to pick up as much as points you can, remembering that increase in points will increase the processing as well. So here I will go and select fewer points on the outer boundary, but I'll try to pick up more points in the region where there is a river and there is a bridge. This way we are trying to add the path in Google Earth where each point is picking up the latitude and longitude of the selected point at the location. But this does not give us the elevation values, but still we are trying to identify the location by each point where it can have its own latitude and longitude. Now you can look here that I have trying to get more points in the river area, which is my actual site of interest. After this I will go to the newer version, or you can say that the recent date after the landslide when the damage has already occurred, and perform the similar exercise. I'll try to create the path and try to pick up as much as point where the damage has been occurring most. After this, when the path has been created, I'll go to the places section in the left corner and I'll click on my path and click save place as, and try to remember that save the file as KML file, not the KMZ file. Try to save it as KML file, which is keyhole markup language extension for Google Earth, and try to save these files. Since you know that the point only had latitude and longitude, but you need elevation values of these points to perform any calculations or operations. So we will get the elevation values from a different site. We will go to gpsvisualizer.com. In this site, it uses different datums or elevation databases which we have across the world to get the best possible fit to the elevation values of our latitude and longitude. So what we will do here is that we will upload our KML file and submit it, and this site will provide the elevation values to our latitude and longitude to the best fit according to the whichever DEM data source suits us best. So once you do that, it will create an output file in GPX format. You do that, this is how you do it, and you can see that latitude, longitude and elevation values has been edited, but this file is in GPX format. For better interoperability, we will convert this file into text format or .txt format. What you can do is go to the convert from and select the file which you have just downloaded, GPX file, and convert it to plain text. Once you do that, you will see an output like this, where your file has been converted, and you can clearly see that latitude, longitude and altitude has been differentiated clearly. So you do that for both the files, and after you are done with the conversion from GPX to TXT file, we will go to the ArcGIS as well, add those files, TXT files, to our table of contents. You can just drag and drop those files. The one trick here is to add such files to ArcGIS. They must have the latitude and longitude because these are the spatial data. So these need to have latitude and longitude to be added to ArcMap. So here I will display those values by right clicking on the file and selecting display data. Here you can select in the Z field altitude values, and you can see that the coordinate system here is unknown, which should not be the case because we know that the Google Earth operates on the system of WGS 1984. So we will select that coordinate system, go to edit option and select WGS 1984. It is a GCS system or geographic coordinate system which is used to display the features on the model of Earth's surface. So once you do that, you display the data and you can see the data has been displayed. But this data is in the temporary form. It has not been saved to a particularly shape file. So what will we do here is that we will export these data so that they can be converted into saved as a permanent file. So right click on the file and click on export data. Also you can see that if your data has been imported correctly, right click on the file and click on show attribute table, and you can see that the latitude, longitude and altitude has been displayed. There are some other fields also. If you don't want to see them, you can select them and click turn field off, so they will no longer be visible in the attribute table. After that, you can export the data by right clicking on it on the file, go to data and export data. Select the folder location, give the file name and select the save as type as shapefile, and once you do that, the data has been saved in a permanent shapefile. It's no longer temporary and you can recall this data wherever you want to load this shapefile. Once you are done with this, now we have individual points, but we don't have the variation or a continuous profile yet. It is a shapefile, not a raster file. To convert this shapefile to a raster file, we will do spatial interpolation between the elevation values of corresponding x and y coordinates. So we'll go to spatial analysis tools, go to interpolation, and we can select different methods are there for interpolation like IDW, Kriging, natural neighbor, you can select the interpolation method which suits you best. Here I'll show you natural neighbor. It's a very fast and easy process to do. There are complex method kriging also, which is a complex method, but I'll try to show you with natural neighbor. You select natural neighbor and drag and drop input point feature. In the Z value field, try to remember this, change the Z value field to altitude unless the interpolation can be very wrong. Save a folder location and save the file as a DEM pre-event. Whatever the file name you can give it, try to be organized so that after time you can recognize what files you are supposed to get. You save it, and in the environment section you can go to processing extent and select it as pre-event. By doing so, you will restrict the interpolation between the points only, and you will have a boundary which will be concluded from the outermost points also. If you don't do it, you will get DEM which will be irregular shaped, or you can say it might be different from what you will expect. So go to processing extent and change it to your layer file and then click OK. After clicking OK, you can see that in the bottom right corner the process is running and you can see the DEM has been created. To make it visually aesthetically pleasant, you can change the symbology and how the data is being displayed. Perform the similar exercise for the post-event DEM also and save it as DEM post. Since all of the data of the post-event and the pre-event, we want a layer which are coinciding with each other. So pre-event you can see is almost inside or circumscribed in the post-events data. So in the post-event environment setting, I'll select pre-event only so that I can have a raster layer which comprises or which have a similar boundaries like the pre-event DEM. Once you do that, you have two DEMs of the pre-event and post-event. Now you change the symbology and you can see this is not a very clear indication, so you can increase the classes and you can have a very clear DEM. Now you do it for the another layer also. Now if you want to have contours generated on this DEM, because several times the input files as well as you want to visualize what is the similar elevation profiles in the DEM. If you go to the search toolbox and type in contour, once you search it, you will have a different options coming. You select contour spatial analyst tool. Once you select that, drag and drop the input raster and give the contour interval. I have a smaller area and small elevation difference, so I'll go with the contour interval of 5 meters only. As you can see, the contours has been generated, but it is not very clearly visible. So what you can do is go to the contour file, right click on it and enable the label features option so that you can see the values of the contours. After that, you can go to the symbology and change its width of the lines or the polylines, color of the line, as well as you can also edit the values of labels which have been displayed so that it is more clearly visible. Once you do that, our final objective is to calculate the change detection, so that for which we can go to spatial analyst tool and we will go to map algebra and go to raster calculator. Here you can see there are two layers available, pre and post DEM. So what we want to do is have erosion and deposition values, so we will subtract one DEM from another DEM. So here I will double click on the post DEM and subtract pre-DEM from it. If I do like this, so if I get a positive value, that means there has been some deposition which was not earlier. If I get a negative value, that means erosion has taken place because the newer elevation value is lesser than what it was earlier. The event occurred. So I'll select the environment again as the pre-event DEM so that file is having a similar area, or you can say the extent is same. Give a folder location, save the file and click OK. This way a DEM of difference has been generated. You can go to properties and change its symbology, like how it is displayed. So once you do that, you can see that the high values are in the bluer shades and low values are in the red shades. So the higher value, positive values are showing a deposition, and red values or the lower values are showing, negative values are showing erosion from the area. But you want to have a clearer picture of how to display that, so that we can do by reclassifying the raster. Go to 3D Analyst tool and reclassify it. Add the input raster value. What I mean by reclassifying is that I don't want to have so many classes here. So I'll only have two classes, like the deposition and erosion only. So I'll classify these files once again by clicking on classify, and I'll select the number of classes to be 2 only. The one class for deposition and one class for erosion. Here you can see that all the negative values are in one class and all the positive values are in one class. So I'll change the one value which is extreme, 0 to negative and 0 to positive. So I know that 1 is for erosion and 2 is for deposition. Once I reclassify, the output will have only two colors, 1 and 2. I can change the color so that it is more intuitive. So after that, you can see the red areas are where erosion has taken place, and 2 is the area where deposition has taken place. So this is how you do change detection by generating DEM of your own from Google Earth. And how do you generate contours also from the DEM. Thank you for watching this video. Tune in later to get some more videos for GIS related videos. Thank you.